Okay, so we have this large team of people working on this project, and when I show you the idea of the Microworld, there isn't anything terribly stunning about it. There are much, for example, if you compare it with NetLogo, it isn't an all-purpose piece of software. By itself, it's designed to solve a particular problem. But I just want to show you the kinds of challenge that we have when we're trying to solve a particular pedagogic problem. And here's the message I want to leave you with, as there's only 15 minutes left, which is, I know that this piece of software, I know that the playground software that we use, and I know that NetLogo were responses to problems that had already emerged in the teaching and learning situation. So I'm sure the NetLogo people, I know the NetLogo people said, there are these amazing phenomena that kids could model if we gave them the tools to do it. Let's build the tools for them to do it. And we said in the playground project, we know that if kids got used to building video games, we could introduce them to a whole load of interesting mathematical ideas that would be difficult otherwise. And this is another example of that. But in this example, we're trying to do one more thing, and I'm just going to have to say it. I'm not going to be able to show you, because I'm not going to demonstrate the software. Over many years, we realized what we should have known at the very beginning, which is, you can have the best piece of software in the world, and if you don't have teachers who care about it, it isn't going to work. We are not anywhere near software replacing teachers. It's an interesting question as whether we should look forward to when they will replace teachers, but I'm pretty confident that nobody in this room is going to see that happen. It's just too difficult a problem of computer science. But we're working with computer scientists who are going to try and support teachers. The idea is, we know that the teacher is essential in the interaction between the learner and the technology. What the teacher says, what the teacher does, what the connections the teacher helps the student make using the technology are absolutely essential. But in the real world, you have one teacher. How many kids in a typical Hong Kong classroom? Okay, so you have one teacher, 40 kids. Maybe you're lucky, maybe you have 40 computers, but that's not only good news, because then the teacher has 40 people and 40 computers that they have to see what's happening. And our idea is we're trying to build an intelligent system, not to tutor the children instead of the teacher. Have you all seen these intelligent tutoring systems that are on the market? Yes. Well, anyway, here's a typical intelligent tutoring system says, here is a piece of knowledge that we would like the kids to have. We chop this piece of knowledge up into 10 little pieces. We take them in sequence through the 10 little pieces, and we tell them whether they're right or wrong each time. And if they're wrong, we take them somewhere else to show them how to get it right. And in the end, they can do all 10 little pieces. And the problem with that is that kids do end up knowing how to solve each of the 10 little pieces, but they have no idea why they're doing it or how it adds up into a greater piece of knowledge. You can imagine me teaching you how to write a program to model the segregation thing, but not mention that there was a big idea behind it. So we don't want to do that, but we do want to see if it's possible to use intelligent techniques, computer science techniques, not to replace the teacher, but to support the teacher. Give the teacher information in a digestible way. At the very least, just think, you know, the kids are all working on the computers. It would be nice for the teacher to know, to have some overall picture of if the students are making progress or not. And this is a really, really hard problem. It's a hard problem because the knowledge doesn't come packaged in a hierarchical way. If the development of understanding of a difficult idea really was linear, you learn this, and then you learn that, and then you learn that, and then you learn that. If that was true, if that's how knowledge was built by individuals, then it would be easy. We would have computer-based learning models that really work. But that isn't how people learn. They learn a little something, and then they try and see where it leads them. They try and connect it to things they already know. And then they might, if the tools are appropriate, they could explore where that little piece of knowledge takes them. And then they might be ready to learn something over here instead of having to go to the next piece. And so these kind of exploratory learning environments are very, very rare in the world. And the computer science community is beginning to understand that. They've spent a lot of time trying to solve a problem that nobody in education needed to solve. And now I think it's true that many of them are beginning to see what the real problem is. And if you look at the proceedings of conferences which are trying to, for example, there's a conference called Artificial Intelligence in Education. And it produces a book like this every year, every 2 years. And if you look through those books, somebody like me who used to look through them and think, well, this is really, I'm sure this is nice computer science, but I'm not a computer scientist, so I'm not very interested in it. But if you look now, you begin to see that at least the problems that they're trying to address are the right problems, which is how can we assist the teacher to assist the pupils, the learners, in doing things that we don't know in advance they're going to do. And that's a really, really difficult problem. So that's something that we're trying to do in our project, and we're 2/3 of the way through.